Howdy, everybody. Hope you're doing well. We are really starting to get into our solving equations unit, and that's where we're going to be headed over the next several weeks. This video is just a quick review of solving one-step equations from 6th and 7th grade. Just wanted to kind of show you some examples and remind you of what it was we're doing with the early stages here. Before we build on anything and make it bigger, we need to make sure we understand the basics. So a one-step equation, the key to a one-step equation is we want to get the variable alone. And that you're going to hear me say that over and over again, get the variable alone. And now with a one-step equation, there's just one thing we typically have to do to get that variable alone, and it's always going to be inverse operation, or do the opposite of what you see. So let's go ahead and flip over to the doc cam here and look through a couple of examples as we go through. So again, we've got our solving one-step equations review section here. So the first thing we're going to look at, our first example, example number 1, could be something like m minus 14 equals 32. So this is a one-step equation. Our goal is to get the variable alone. So you always need to locate the variable. I'm going to be moving this variable around through my examples, so you have to pay close attention to where it is and what we're doing. We have m and we're subtracting 14. So in order to get rid of the 14, we've got to do the opposite. We have to do the opposite of minus 14, which is plus 14. Now I'm going to have you guys write the plus 14 right underneath it. A minus 14 and a plus 14 cancel out because when I put them together, they make nothing. Now we're going to give our little divider here through the equals sign. One of the keys when solving equations is whatever I do to one side, I have to maintain balance. I have to do it to the other side. So if I add 14 on this side of the equals, I have to add 14 to the other side of the equals. The 14s cancel out because they make nothing. I'm going to bring the m straight down. I'm going to bring the equals straight down. And then here I'm just going to do my integers. 32 plus 14 is pretty straightforward integer work, and we're going to get 46. So for that first example, m equals 46. M is alone. I have solved the equation. Now, what if I move things around and change my integers and make them a little more complex? Let's make this negative 17 plus the letter r equals negative 31. So again, I need to locate my variable. I've now moved it over here. And I'm going to create my little barrier down the middle. In order to get r alone, you have to ask yourself, what number do I need to get rid of? And for this example, I have to get rid of the negative 17. Well, I have to do the opposite of negative 17. And the opposite of negative 17 is positive 17. So I'm going to put a positive 17 right underneath it. The negative 17 and positive 17 cancel out. Now remember, maintain balance. Whatever I do to one side of the equals, I have to do to the other. So if I added 17 here, I have to add 17 here. The 17s cancel out. I bring down the r, I bring down the equals. And then this right here, you have to be careful. This is integers. This goes back to the first week of school. If I have a negative 31 and a positive 17, those are different signs. So I'm going to subtract and keep the sign of the larger number. Now the larger number is 31, so it wins. And when I subtract those, a negative 31 and a positive 17 is going to make negative 14. Okay. My r is alone and r equals negative 14. Now let's change operations here for example 3. Let's take something that looks like this. Let's take 5x equals 40. Well, now the 5 is touching the variable. If they're touching, that means multiplication. There's nothing separating it. There's no plus or a minus. So if they're touching, it means multiplication. So this means 5 times x. Well, the opposite of multiplication is division. Well, the key to division is we're going to use the fraction bar. So 5x, I'm going to divide by 5. If I have a 5 on the top and the bottom of a fraction bar, then those reduce away and cancel out. But remember, I have to maintain balance. So whatever I do to one side of the equals, I have to do to the other. So if I divide this side by 5, I have to divide this side by 5. Well, the 5's canceled out over here, and x equals 40 over 5, and 40 over 5 is going to make 8. Again, x is alone, so you've got your 40 over 5. I'm going to go with example 4 here. And let's go ahead and take a problem that looks like this. We're going to move things around on you a little bit. Let's make it 20 equals x over 3. I've now moved the x to the other side of the equals. That doesn't matter. My goal is still the same. It's to get x alone. Now, x is in a fraction, and a fraction bar means divide. So this right here means x divided by 3. So I have to do the opposite of divided by 3. So I am going to multiply by 3. Now I want you to use the dot for multiplication, and I want you to make sure to put the times 3 next to that fraction. Remember, whatever I do to one side, maintain balance and do to the other side. So I'm going to cancel those out. And x equals 3 times 20, which is going to be 60. It is okay for the x to be on the other side of the equals. There's nothing wrong with that. Now I'm going to put together a couple of examples here that I want you guys to try on your own, and I'm going to move the variable around, and I want you to think about these examples that you just copied down, and we're going to put them here. So our examples that I want you to do. Let's go ahead and move things around. Let's make this negative 15 equals x minus 3. And then I want to do this example, which is going to be x plus 7 equals 12. And then I want to do one over here that's going to be 7 equals x over 4. And then finally, negative 5 equals 5x. I want you to go ahead and pause the video for a moment right now and try those 4 example problems. All right, now that you have finished those 4 problems and resumed the video, let's go through these real quick to see how you did. Your homework assignment tonight is going to be very similar to these problems. If I want to get the x alone, I need to get rid of the minus 3, and the opposite of a minus 3 is plus 3. So those cancel out. Don't forget your integers. A negative 15 and a positive 3 is going to make negative 12. Over here, if I want to get x alone, I have to get rid of the plus 7. The opposite of plus 7 is to subtract 7. 7's cancel out, and 12 minus 7 is 5. Oops, I missed the x there. Let's put boxes around those. Example number 3, the x is in a fraction, so that means x divided by 4. The opposite of divided by 4 is to multiply by 4. So I'm going to multiply both sides by 4. And x equals 28. The last example here is going to be 5 touching the x. That means 5x. It means 5 times x. And the opposite of multiplication is division. So I'm going to divide both sides by 5. Negative 5 divided by 5. Well, there's one negative in that fraction. So remember, one negative in multiplication and division is going to make a negative. And 5 goes into 5 one time. So that's going to be x equals negative 1. So that's a quick review of one-step equations. Hopefully this was pretty easy for you because it should be already covered in 6th and 7th grade. On your homework, there are a couple problems that have some fractions in there, but I want you guys to try those on your own before I show you how to do them. Just use your basic fraction skills, and if you've got questions, you can come see me in class and we'll go over them. Hopefully this helps, and I will see you guys later.